Just take a second and look around you. Right now, your phone, that coffee mug, the chair you're in, they all just kind of seem to be there, right? Like they just exist. But the truth is, they don't. And we're about to pull back the curtain on the incredible story of how they're actually made.
A supermarket manager named Bill put it perfectly. He said his job is basically running a magic show. We're the audience, we walk in, and poof, the exact thing we want is right there on the shelf. We never have a clue how the trick is done.
But what if we could peek behind that curtain? I mean, how does this massive global magic trick actually work? Well, that's exactly what we're going to unpack.
Let's start at the place where this illusion is performed thousands of times a day, every single day, your local supermarket.
So, picture your average supermarket. How many different kinds of products do you think are on those shelves? The number is just wild. 30,000. And listen, that's not 30,000 cans of soup, that's 30,000 types of items, what the people in the business call SKUs, or stock keeping units.
Yeah, this really puts it into perspective. Every single one of those 30,000 product lines has to be made somewhere, shipped somehow, and stocked on a shelf. When you multiply that across thousands of stores, you're talking about millions of individual items, all part of this incredible choreography to be on the right shelf at exactly the right time just for you.
Okay, so now let's zoom out. From that one store to the planet-spanning systems that make all of this daily magic even possible. Think about your smartphone. Before that device ever got into your hand, all of its components traveled a combined total of at least 250,000 kilometers. To put that in perspective, that's like circling the entire Earth more than 6 times. It's just a mind-boggling journey for one little device.
But here's the catch. This incredibly efficient, globe-trotting system that delivers our lives to us, well, it's also incredibly fragile.
And the reason it's so fragile is because in our relentless drive for lower costs and faster delivery, we've adopted ideas like just-in-time manufacturing. That's where parts show up exactly when they're needed, which means companies don't need costly warehouses. We've basically engineered out all the slack. We've built these incredibly complex systems with absolutely no plan B. So when something unexpected happens, a giant ship gets stuck in the Suez Canal or a global pandemic hits, the whole magic show can just grind to a halt.
To really get how we built this fragile marvel, we need to take a quick trip back in time and see how the very act of making stuff has been completely revolutionized over the years.
For centuries, pretty much everything was made by hand. Then, boom, the first industrial revolution hits. We get steam power and we move from tiny workshops into factories. The second revolution brought us electricity and the assembly line, which made true mass production possible. And then, the third brought computers and automation right onto the factory floor.
Now, a huge driver of that third revolution was this game-changing idea that came out of post-war Japan, the Toyota production system. Instead of just cranking out as much stuff as possible, the focus shifted to making things efficiently, reliably, and with almost zero waste. All of a sudden, quality became just as important as quantity.
Which brings us right up to today, and the next massive transformation, the birth of the smart factory.
This didn't just happen overnight. First, you had these giant mainframe computers that let big companies analyze data, but it was slow. Then, the PC brought that computing power right down to the engineers on the factory floor. And now, we've got the Internet of Things, or IoT, which connects every single machine, giving us a constant stream of real-time data. We've gone from slowly analyzing the past to optimizing the present instantly.
So, with this flood of data, we can do something that sounds like it's straight out of science fiction, the digital twin. Imagine creating a perfect virtual copy of a real-world object, say a jet engine. This digital version is fed live data from the real engine, letting you monitor, test, and even predict its behavior in real time without ever laying a hand on it.
To see just how powerful this is, you just have to look at Rolls-Royce. They use digital twins for every single one of their jet engines. So while an engine is screaming along at 35,000 feet, engineers on the ground can watch its health, predict exactly when it'll need maintenance, and even figure out ways to make it more efficient, all from a control room thousands of miles away. It's incredible.
All of these amazing advancements have literally built the world we live in today. But you know what? They also give us the tools to build a better one.
So where does all this tech and knowledge take us? What's the next act in this global manufacturing story?
Well, the future seems to be focused on a few key ideas. Instead of our old make, use, and throw away model, we're moving towards something more circular. We're learning to repair things instead of just replacing them. We're learning to reuse and remanufacture old products into new ones. And maybe most radical of all, we're starting to rethink the whole idea of ownership itself. I mean, imagine paying for a subscription to use a power drill whenever you need one instead of buying the drill. You're paying for the service, not the object.
And this really brings us full circle. It's a reminder that everything is manufactured, even the very book this research comes from. As you can see here, it has its own complicated production story. A digital file becomes printing plates, giant presses print the pages, which then get folded and cut. At the same time, the cover is printed and bound. Finally, a machine smushes them all together, and the finished books are shrink-wrapped and shipped out. It's a whole factory in motion, all just so these ideas can get into our hands.
Ultimately, what all this really shows us is that we are the architects of the world we live in. We design it and we manufacture it. So the real question isn't how we make things anymore. The question is, with all this incredible knowledge and power, what kind of world do we want to make next?